Hello and welcome to Math 200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a problem from section 6.2. This is problem number 1. We have on the planet of Mercury, 4-year-olds average 2.9 hours a day unsupervised. Most of the unsupervised children live in rural areas considered safe. Suppose that the standard deviation is 1.6 hours and the amount of time spent alone is normally distributed. We randomly survey one Mercurian 4-year-old living in a rural area. We are interested in the amount of time X that the child spends alone. This is a source from Mercury News, San Jose Mercury News. We want to round off all the answers to 4 decimal places when needed. So our first question is asking us to identify our normal distribution. And if you remember, the normal distribution is a random variable distribution, a continuous one, and it usually would be denoted by n parentheses, and then we want our mean and our standard deviation. Well, we have our mean and our standard deviation identified, so those are going to be the 2 values that we're going to want for this first one. So we're going to be putting in 2.9 in for the mean and 1.6 in for the standard deviation. All right. The next one, they want us to find the probability that a child spends less than 2.8 hours per day unsupervised. So here is when we're going to need some sort of technology. And the technology preferred is going to be Google Sheets. So let's bring in Google Sheets here. I'll put it here. And we are interested in finding out some sort of probability. So maybe we can identify the mean first. Our population mean is going to be 2.9, and our standard deviation is 1.6, and that was given in the problem. Now the first problem, or the part B, is asking us the probability that a child spends less than 2.8 hours. So essentially what we have is the probability that X is less than 2.8. Now the commands that we have for our Google Sheets would be the norm.dist or norm.inv. So norm.dist would give us the areas under the normal distribution, or equivalently it would give us the probability. So in this case we're looking for the probability. And the fact that this is less than 28 means we're going to be able to use the cumulative normal distribution. So this will end up being equals norm.dist, and then our X value that we want to put in is going to be the 2.8. And then we're going to say comma, and then the mean 2.9 and the standard deviation 1.6. And remember that we're always going to be looking at the cumulative, so this is going to be labeled as true. All right, so it looks like our value is going to be we want to round off to 4 decimal places, 0.47508, so 475.1. Let's actually capture this so that we can put it in our notes here. Oops, that didn't work. Let's just get the answer then. So we're looking at the answer to be 4751. That's 0.4751. All right, so that's our first probability. And now the next one is what percent of the child By the way, these things have an associated drawing with them, and it would be good to kind of have this every once in a while. The drawing will start off with a normal distribution where our mean is right in the middle, 2.9. And then what you want to do is you want to label your x value that you're considering. So this is less than 2.8. So 2.8 is somewhere over here, 2.8. And then we're looking at this value. So this would be a good idea just to get a quick visual of this and say 2.8 is fairly close to 2.9, but it's not exactly 2.9, and we're shading the left side. So we're looking at something that's almost 50%, almost 0.5, and it's a little bit short of that, and our answer for 0.4751 kind of confirms that. All right, so speaking of graphs, for the next one we'll do a graph. What percent of the children spend over 4.7 hours in unsupervised? So I would again draw my bell-shaped curve. I'll put the 2.9 here, and then we want to shade in from 4.7. So 4.7 is over here. We can be really technical as to how many standard deviations away that is, but we can just approximate somewhere over here, 4.7. So, and then it's going to be on the right side. So it's the complement of the cumulative distribution. Remember that the norm.div function or dist function, 4.7, and then 2.9, 1.6, and then cumulative. So remember that this would capture the area that's cumulative on the left side. And so to get the area that we actually want, we need to subtract this from 1 or 100%. So it'll be 1 minus this command. So this is going to be what we need to put into our Google Sheets. So if we take that and put those values in, we should get what we want. So in this problem, again, we're looking for the probability that x is bigger than 4.7. And so that's going to be the 1 minus norm.dist, and then we have 4.7 comma 2.9 comma 1.6, our mean and our standard deviation, and cumulative is true, and then we get 1.3029. So 0.13029, or that's going to be 0.1303. So this is going to give us 0.1303, which makes sense. It should be kind of a small number because it's farther out, and it's going to be less than 50% for sure. Now, if we notice here, the particular problem is asking us to put a percentage, and so to make this into a percent, just move the decimal place a couple units to the right, and so it's going to be 13.03. So it's going to be 13.03% as opposed to an actual decimal. Okay, now the last one is a little bit tricky because it's going to require an inverse norm, and let's see what it's asking. 88% of children spend at least how many hours per day unsupervised? So if we were to draw out our graph again, and then we have our 2.9 here, and then we want to know 88% of the children spend at least how many hours. So at least, this at least is kind of looking at the bigger than sign. So I think they want us to figure out the 88% of an area. So this is the area or probability that we're looking for, or that we're given. We're not looking for it, it's actually given. So the shaded area here is going to be 88%, or 0.88. Now, if we're going to take advantage of technology and try to figure out this number, because this is the number we want, what is this number? Most of the inverse normal inputs that we need to put in any technology, whether we're using calculator or this program, Google Sheets, that is always going to ask for the area on the left. And so if this is 88%, then this is going to be the complement of 88%, which is going to be 100 minus 88, and I think that's 12%. And so we're going to want to put in 0.12. All right, so back to our program, our Google Sheets program. If we're looking for essentially we're looking for the 12th percentile, and to get that, I'll put it down here. We're gonna call on the inverse norm function. So this is going to be norm.inv, and then now we have to find the area to the left, and so this is where we get the 12%. So 0.12 for 12%, and then the mean, the same mean that we've been dealing with, that's 2.9, and the same standard deviation that we've been dealing with, and then that's all you would put in. So that would be 1.02 would be the answer for that. So let's put in the command that we're using. We're saying norm.inv, and then the area on the left is going to be 0.12. The mean is going to be 2.9. The standard deviation is going to be 1.6. And then our result was 1.02. And does that make sense? According to our graph, this is 2.9. We're definitely expecting a value of hours that's less than 2.9. So it does make sense. I mean, if we would have gotten a 4.5 here, we know that would have been wrong because we're expecting a number less than 2.9. So this is going to be 1.02 hours. Okay, I hope that helps. Good luck.